Welcome to geometry class. Today we are going to learn about the Pythagorean Theorem and its converse. So you've probably heard of the Pythagorean Theorem before. In a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So we better know what legs and hypotenuse are. So the two legs of a right triangle are the sides that touch the 90-degree angle. So one leg and the other leg both touch that 90-degree angle. The hypotenuse is the longest side of the right triangle. It's the one across from the 90-degree angle. And it does not touch the 90-degree angle. Okay, so now that we've established that, we know that if the A and B are on the legs and C is on the hypotenuse, then we can use this equation, A squared plus B squared equals C squared, to relate the three side lengths on this triangle and solve for a missing side length. So the numbers A, B, and C form a Pythagorean triple. There are some common Pythagorean triples that come up in a lot of geometry problems. If you remember these, you won't have to use the Pythagorean theorem to find the missing side because you'll already know what it is. So 3, 4, and 5 are a common Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared. Also, 5, 12, 13 is a common Pythagorean triple. 8, 15, 17 is a common Pythagorean triple. And 7, 24, 25 is a common Pythagorean triple. If you remember those, you don't have to do the work. You can just write down the answer. But also, if you have multiples of these common triples, it will work too. So like if I doubled each of these numbers and had 6, 8, and 10, that would work. Or if I multiplied each of them times 10 and had 30, 40, and 50, that would also make a Pythagorean triple. So not just these, but also multiples of these. And there are infinitely many more Pythagorean triples, but these are the 4 that we tend to use the most. Okay, so let's go down here to number 1. We have the two legs of the triangle are 3 and 3. These are the sides that touch the 90, and we're trying to find the hypotenuse. So we're going to use our good old A squared plus B squared equals C squared formula. And so I'm going to put 3's in for the A and the B. 3 squared plus 3 squared. And the missing side here, we can leave it as C, or we could change it to X. Since they have the X in the problem, I'll use X here. So 3 squared is 9. So 9 plus 9 equals X squared, and 9 plus 9 is 18. And then to get the square off the X, you have to undo the square. The opposite of squaring a number, of course, is taking a square root. So the square root of 18 is equal to the square root of X squared. And the square and the square root cancel each other out. Then that means that the answer is the square root of 18. And you could give your answer, as a decimal or as a simplified square root. We'll probably mostly do decimal answers. So the square root of 18 is going to give us 4.2. We'll just round to the 10th place for these. 4.2 is the answer we're looking for. Okay, take a look at number 2. On this one, they give us the hypotenuse and they ask us to find one of the legs. This is the leg, this is a leg, and this one across from the 90 is the hypotenuse. So when we do A squared plus B squared equals C squared, we're going to go 9 squared plus X squared equals 15 squared. Whichever side is across from the 90 is the one that has to go all by itself in the formula. So 9 squared means 9 times 9, so that's 81. and 15 squared is 225. And we're going to get that x squared by itself. So since it's got an 81 added to it, we're going to subtract 81 from both sides to get the x squared by itself. So that's going to be 144. And then again, to take the square off of the x, we do the square root to both sides. So x is equal to 12. And I know that the square root of 144 is 12 because 12 times 12 is 144. But feel free to use your calculator if that helps you. Now, turns out this is one of those that we could have done using a Pythagorean triple. Because if you look, this is your 3, 4, 5 pattern multiplied times 3. 3 times 3 is 9, 4 times 3 is 12, and 5 times 3 is 15. So 9 was given, 15 was the hypotenuse, and 12 was the answer. So that would have been another way to approach this problem. You can still use the Pythagorean theorem, but it might be faster if you recognize it as the multiple of one of those Pythagorean triples. Okay, for number 3, we have a leg given. We're trying to find a leg, and the hypotenuse is also given. That's the one across from the 90. So we're going to use our a squared plus b squared equals c squared formula. And we'll put 25 for one leg, x for the other, and the hypotenuse is 65. Now, if I wanted to put the x here and the 25 here, that would have been fine because a and b you can mix up with each other. It won't change the math at all. But the c side definitely has to be the hypotenuse side. If you mix it up and put it in the wrong place, you're going to end up with an incorrect answer. Okay, so 25 squared is 625 plus x squared equals 65 squared. And 65 squared is 4,225. And we're going to subtract 625 on both sides to get the x squared by itself. So I'll go minus 625, 3,600. And then we're going to take the square root on both sides. So x is equal to 60. And that is the answer for number 3. Okay, now we're going to go over here to problem 4. This one has fractions. Again, we're missing a leg. We're given the hypotenuse is 5/9, so we can go a squared plus b squared equals c squared, x squared plus 4/9 squared equals 5/9 squared. So x squared plus 16/81 equals 25/81. And I'm going to subtract 16/81 from both sides. So let's see. I'm going to be left with x squared equals 25 minus 16 is 9/81. And then if I take the square root on both sides, x would be equal to 3/9, which simplifies to 1/3. So the answer is 1/3. And you can use your calculator to do the square root of a fraction. Just go second and hit that square root button, which is the x squared button right here. And then you can hit the green alpha button and the y equals button, which will give you this n/d, which is numerator denominator. And you can type 9 on top and 81 on bottom and press enter, and it gives you your 1/3 for your answer. Okay? Now, let's move on to number 5. This one they've drawn a little rectangle, but we still identify this right triangle. We have two legs and we're trying to find the hypotenuse. So we can use a squared plus b squared equals c squared. 16 squared plus 33 squared equals x squared, because that x is the hypotenuse. 16 squared is 256. 33 squared is 1089. And those add to make 1345. Now if I take the square root on both sides to cancel out that square, that number is not going to be an exact answer. The square root of 1345 is 36.7. So 36.7, that's rounded to the tens place, is what x is. And really, I ought to change this to a wavy equals. Like over here, I should have had a wavy equals for approximately equal to, and I'm rounding it off, but it's fine. All right. Let's go down here to the bottom, and it says, use a Pythagorean triple to find x. Now these problems you could do the same way that we did the others, or you could do them really quickly if you know those Pythagorean triples. So we had one that had a hypotenuse of 17, do you remember? It was the 8, 15, 17. So if I know that, I can just go x equals 15, the end. Now here, I didn't give you any numbers as big as 45 or 24, did I? But I know that 45 and 24 are both divisible by 3. And if I take 45 and divide it by 3, that gives me 15. And 8 divided by 3 gives me, 24 divided by 3, I gave it away, sorry. 24 divided by 3 gives me 8. So look, 8, 15, that's what we just had. So this one would be 17, except for not just 17. You got to do 17 times 3 more to give you 51. So when you take 51 and divide it by 3, it would give you that 17 for the pattern. So the answer is x is equal to 51. Now you can still do this using a squared plus b squared equals c squared. It just might be a little faster to do it this way. And here's the last one that they said to do using a Pythagorean triple. So let's see, 28 and 96, I believe, are both divisible by 4. They're both divisible by 4. So if I divide this by 4, I get 7. And 96 divided by 4 is equal to 24. So we had the 7, 24, 25 one. So I do 25 times 4 to give me 100. So x is equal to 100. Because 100 divided by 4 would be 25 for that pattern. Okay? Feel free to still use the Pythagorean theorem on those problems. If you find it easier for you, that's fine. Okay. Now, on the next side, it's the converse of the Pythagorean theorem. If the sum of the squares of the lengths of the two shorter sides of a triangle equals the square of the lengths of the longest side, then the triangle is a right triangle. So if a squared plus b squared equals c squared, then you know you're looking at a right triangle. So you can test it out to see if it does equal a right triangle. Now if you do a squared plus b squared and you get a number larger than c squared, then that means it's an acute triangle. And if you do a squared plus b squared and you get a number less than c squared, then that means you're looking at an obtuse triangle. So this information up here can help you determine which kind of triangle you're looking at. Okay? So let's look at these problems down here. It says, determine whether each set of measures can be the sides of a triangle. Now, do you remember how we did that earlier this year? We looked to add the two small sides. And when you added the two small sides, you had to get something greater than the largest side to make a triangle. Otherwise, they won't even connect to make a triangle. So if it makes a triangle, we're going to classify the triangle as acute, obtuse, or right by checking and comparing the values of a squared plus b squared with c squared, okay? So look at this first one, number 1, 30, 40, 50. First of all, is this a triangle? Let's add the two small sides. 30 plus 40 equals 70. 70 is bigger than 50, so yes, we have a triangle. But let's see what kind it is. If I go 30 squared plus 40 squared, I want to compare this. Is this equal to 50 squared? Okay, so we can use a calculator to do this. We're going to go 30 squared plus 40 squared is 2,500. And let's compare that to 50 squared. Oh, 50 squared is 2,500 as well. What do you know? They are equal, which means this makes a right triangle. Okay? Now let's look at number 2. We're just going to do 4 of these. On number 2, we're going to add the two shorter sides. 20 plus 30, that's 50. 50 is more than 40, so we can make a triangle out of this. Now let's check to see what kind of triangle it is. 20 squared plus 30 squared, let's compare that with 40 squared. Are they going to be equal? Let's find out. 20 squared plus 30 squared. Oops, I pressed the wrong button. That won't help me. Oops. All right, Miss Heiss, get it together. 20 squared plus 30 squared is 1,300. Now, let's compare that to 40 squared. What is 40 squared equal to? 1,600. They're not equal, so it's not a right triangle. 1,300 is less than 1,600. Do you remember what kind of triangle that's going to make? If a squared plus b squared is less than c squared, then we have an obtuse triangle. So I'm going to write obtuse here. All right, number 4. First, I'm going to add the two littler sides. 6 plus 8, that's 14. 14 is greater than 9, so we can form a triangle with these side lengths. Now let's see what kind of triangle it is. 6 squared plus 8 squared, we're going to compare. Is this going to equal 9 squared? Well, let's see. 6 squared plus 8 squared is 100. And 9 squared is 81. Well, they're not equal. 100 is greater than 81. So do you know what kind of triangle that's going to make? If it's greater than, it's an acute triangle. If a squared plus b squared is greater than c squared, we have an acute triangle. So since we got the a squared plus b squared is greater than c squared, it's an acute triangle. Okay, here's our last one. Add the two little sides. 6 plus 12, that equals 18. Uh-oh, the longest side is 18. That's the same thing. It has to be greater than the largest side to make a triangle. So since 6 plus 12 is equal to 18, this is not a triangle, because the two shorter sides added together must be greater than the biggest side. Otherwise, these two sides, if they're equal, will just kind of fold down flat and they won't actually open up to make a triangle. So this one doesn't even form a triangle. And that's because of the triangle inequality property that we learned earlier this school year in the fall semester. Okay, so we've taken a look at how to use the Pythagorean theorem, Pythagorean triples, and the converse of the Pythagorean theorem to classify triangles. So hopefully you are all set to do awesome work on your assignment today. I hope you have a great day. Please let me know if you need any help, and I will talk to you again soon. Bye for now.